Hi everybody. So this is for lesson 2. I'm making 2 videos. So this one is to do with this worksheet which I have put for your lesson 2, and it's a revision of what we did in year 12. So this diagram shows two sources close together and they're producing circular wavefronts, and these circular wavefronts interfere with each other. Now the thing is, they both produce identical waves. That means the wavelength, the wave speed, frequency, they're all the same. Okay, and so what I've done, just to make it easier, I've color coded them. So one is green and the other is red. And the other thing you want to see is there are alternate bold and dotted lines. So the bold lines stands for the crest, the dotted lines stands for the trough. Okay, and then you know where a crest interferes with a crest, you get antinodal lines, and where a trough interferes with a crest, you get nodal lines. Now, this is your central antinodal line. All these nodal and antinodal lines have got what's called an order number. So the central antinodal line has got the order number 0. Okay, the next antinodal line is this bold one here. So these are your antinodal lines. I forgot to write that. Okay, and the other ones are your nodal lines. So I've numbered them 1 and then 2. So it's 0 in the center and then it goes upwards. So the red ones, 1 and 2 on this side and 1 and 2 on that side, are your antinodal lines. Your nodal lines are these dotted lines where you can see a trough is interfering with a crest. Okay, so that they have a cancelling effect. So they are also numbered 1 and 2 and so on. So from the center outwards. Okay, so those I've labeled in green. Okay, so when the waves pass through each other, they interfere in such a way that the resultant wave is a combination of the displacements of the two individual waves, and an interference pattern is set up which will consist of a series of nodal and antinodal lines. Antinodal lines are formed where the crests and troughs from one wave meets the crests and troughs from the other wave. This constructive interference creates double crests and double troughs, that is, a line of large amplitude. Nodal lines are formed where the crests from one wave meet the troughs from the other wave. This destructive interference creates a line of 0 amplitude. So we've labeled the lines and we've also numbered the lines. Okay, so apart from the central antinodal line where n is 0, at any point on the diagram, the wave from one source has had to travel a different distance than the wave from the other source. This is called path difference. And so for an antinodal line, the path difference is n lambda, and for a nodal line, the path difference is n minus half lambda. Okay, now I'll just do this question with you. So here's the diagram, and there are two ships, one at x and one at y, and we know that the wavelength, that's the distance from one crest to the other, is 6 meters, and the wave speed is 2 meters per second. We don't really need the wave speed, it just tells you it's a traveling wave. Okay, now the thing is, x is along the central antinodal line where the path difference is 0, but y is 24 meters from one and 27 meters from the other. So the path difference of x is 0, so it's along an antinodal line. So what's going to happen to the motion? It's large amplitude. So it's going to be bouncing up and down with large amplitude. Whereas y, because it's along a nodal line, is going to be quite calm. Okay, so that's the answer to this worksheet here. Now I'll stop this video, it's a short one, and I'll do another one with the theory of two-slit interference, and that's the new bit for year 13. But make sure you've understood this part first. Okay?